cutie patootie math angel. Welcome back, welcome back, welcome back. A very warm welcome if you are new around here. This is Decaf-Math ASMR, and I hope that you're doing well, that you're having a lovely week, a week as lovely as you are. And of course that's my wish for you, but it's totally okay if you're not feeling perfectly peaceful or perfectly positive. There's plenty of love for all of us here, and for that I'm grateful. And I'm grateful that we're here together right here and right now, and that we have whatever resources we need to be able to connect in this way, be it an internet connection or just enough safety to be here and right now. So I'm going to rejoice in that and celebrate with a little bit of math as we do. And today I thought that we could take our time and chat about rates and ratios and proportions. And we're going to take our time. There's no rush at all. So if you're looking for a quicker how-to tutorial, it's probably not the video for you, but for everybody else, I hope that this is extra comforting, relaxing, soothing. I hope that if you are learning this stuff, that I say at least something that is helpful or kind of gets you to think about it. But otherwise, feel free to just zone in and out as you please. If you need the rest, maybe you can allow yourself to close your eyes, to drift off to sleep. Or maybe we can catch a tingle or two, tingle or two along the way. So today we're just going to focus on the intuition. I've been saying that a lot lately, but I want us to get a feel for the math. That's how we fall in love. It's not through our minds, but in our hearts. So let's fall in love with this. That means we're not going to get too caught up in all the little details yet. We will. It's also fun. But for now, let's look at what a ratio actually is. So I don't normally plan out what I'm going to say in these kinds of videos, but I was thinking about it earlier today, and I realized that it's kind of hard to define what a ratio is without using the word ratio or proportion. And that's just kind of cyclical. You don't really want to define what you're trying to define with the word that you're trying to define. So it's kind of like if you're trying to, define what the color blue is, aside from, literally with all the little wavelengths, but you might end up defining it by describing things that are blue instead of it's just hard to define, right? Now all I can think about is the color blue, but we're gonna let that go. And what I think I'm gonna do is start with an example. So an example of a ratio, and then maybe we can kind of get a definition through that, and I'm sure that you could come up with one way better than I can. But really, before I do that, at the core, just mathematically, ratios and proportions are just all about fractions and equivalent fractions, basically. But that's the math side of stuff, right? So we want to actually interpret what we're looking at and give some context to these fractions. So that's what we're focusing on today. So for our example, for a ratio, let's say that I'm making a recipe for some dough, okay? So I don't actually know a dough that has this actual ratio, but we're trying to keep the numbers nice. I don't think it's quite pizza dough, and I don't think it's quite bread dough. You can let me know. But let's say the recipe that we have says for every 1 cup of flour, I need 2 cups of water. So for every 1 cup of flour in my dough, I need 2 cups of water. Okay, so I'm going to write that down just so we don't forget it. For every 1 cup of flour, I need 2 cups of water. So before doing anything with ratios, if I were to say, hey, can you triple this recipe for me? Intuitively, you might go ahead and triple each ingredient. If there's more, you would triple all of those as well. So you might mix up 3 cups of flour, because 1 times 3 is 3, and 6 cups of water, because 2 times 3 is 6, right? So you might decide I'm going to triple each thing and smush it all together and hopefully triple my recipe. Now, of course, sometimes when you do that, you have to change the recipe a little bit, change the baking time, etc., etc. But for the most part, that's what you would get as far as ingredients go, right? So if you were to do that, you've basically unknowingly worked with the ratio. How so? Well, basically, the ratio is this relationship, this 1 cup of flour to 2 cups of water. So when I say this thing, I'm doing it on purpose. It's kind of relating the amounts in a particular way. Like I said, it's actually like a fraction. So I'm going to go ahead and make this a fraction by just putting a line through it, or between them. 1 to 2. 1 over 2. Like so. So this is now a new way for us to interpret what a fraction is. So we've done a bit of fraction work here on this channel. We can think of this as 1/2, but we can now look at this as a 1 to 2 ratio, which is also sometimes written like this with a little colon in between. For math, we usually focus on the fractions, 1 over 2, like so. But now there's just a secret little interpretation to this. It's 1 to 2. Now, you can think of that as being there's half as much flour as water, but that's a relative ratio and proportion. Here we go. But that's a relative amount because we don't know if half as much means, 5 to 10, 6 to 12, 100 to 200 cups of flour. That doesn't matter. They all have the same ratio. It's always half as much flour as water, so a 1 to 2 ratio is the ratio for flour to water. Or you could even flip it the other way and go the ratio from water to flour is 2 to 1, or there's twice as much water as flour. So these are all different ways to look at the same kind of idea. So how do we condense this? Well, it's basically relating different values, right? In this way, we're relating different values, but more specifically, what made this a ratio was this multiplicative relationship. So the key phrase in my bread recipe thing is for every 1 cup of flour, I have 2 cups of water. That implies this multiplication thing, because if I have 1 more cup of flour, I have 2 more cups of water. If I keep adding 1, 1, 1, 1, 1, I'm adding 2, 2, 2, 2, 2, which is this 1 to 2 ratio. It implies this: if I multiply the top, I multiply the same number by the bottom to keep that ratio. So that's my best definition. Would probably be comparing two values or measurements in this fractional way, and specifically with a multiplicative or division, the inverse of multiplication, in that manner. So in other words, you wouldn't ever really add 7 on the top and then add 7 on the bottom, because that would not be an equivalent fraction in general. So it's all about multiplication and or division. So not bad, right? If you have a better way of explaining it, feel free to share it. But that's my best shot for ratios, and conceptually that lines up with the math, so we're not going to get too bogged down with the rest. And now when it comes to proportions, we are basically trying to get the actual values. So this is our like reduced ratio, it's 1 to 2, but now we might ask, how much water would I need to make this dough recipe if I have, let's say, 6 cups of flour. So I'm given an exact value or measurement, and now I want to solve for how much water I would need to use up all that flour for this dough. So that means I set up this equation. So I'm still given this 1 to 2 ratio for flour to water. So now I set this up as an equation, and I want to know how much water do I need to mix with 6 cups of flour. So the how much is a question, so that's what we're solving for. So that let's just set as x, the amount of water that we would need, let's set x. And then the other value is 6, right? 6 cups of flour. So do I put the 6 up here or x up here, and do I put the 6 down here or the x down here? Well, all that is, in order to determine that, is we just need to keep our ratios consistent. So it's flour to water, so we need flour to water. So let's just make a little note there. And we're talking about cups, but you could change this to cups and tablespoons or pints or whatever other units. That's okay. Just make sure that you're consistent throughout. So for 6 cups of flour, we'll put the 6 there for flour. We want to know how many cups of water. So let's put an x, right? We could put question marks, but let's solve for x. So now we have an equation. 1/2 equals 6 over x. Again, cups of flour to cups of flour, cups of water to cups of water. If your units are different, you may need to convert them, but usually this is our basic proportion. So what we get for x is an exact number of cups of water, right, to use up all this flour for our dough. And note that we want to keep this 1 to 2 ratio. So now it's about the exact actual value, not just a fraction here. So here we have one variable and one equation. So usually we call this whole thing a proportion. Okay, just setting this up. Some teachers will use the word ratio or proportion interchangeably. It's okay, the idea is all the same. But this is how I like to define a proportion, is setting up the actual value, so not necessarily a reduced ratio, but setting this up so that we can solve. So at this point, this is all algebra here. So we have one equation with one variable. In this case, we know it's not going to be 0, so we don't have like a dividing by 0 issue. So you can solve this however you like. You could take the inverse of both sides if you like. To do x over 6 is 2 over 1, and then solve. You can multiply by x, do a little bit of fancy multiplication kind of stuff. So you can do whatever you want with this to try to isolate x, and you want x equals something, okay? one little trick that I will point out now, just because we've actually mentioned it before here on this channel, that might come in handy for future problems, is this idea of cross multiplication. So what that means is, and I do have a video on this, so I'll link it down below if you want to actually derive why it works. It's just a little bit of algebra work. Convenient conclusion is that you can, if you have the situation like a over b equals c over d with this equals, you can cross multiply the values and set them equal to each other. So in other words, I can do 2 times 6. So 2 times 6 is going to equal x times 1, which is just x. So x equals 12. In this case, x equals 12. So I'm actually going to go ahead and put a dot there for our times because we do have an x here. So x equals 12. In other words, 1 to 2 is equal to 6 over 12, because 6 over 12 reduces to 1 over 2 if you divide by 6 on the top. 6 divided by 6 is 1, and divide by 6 on the bottom. 12 divided by 6 is 2. So we have an exact value. So x is 12. And to make sure we have our units, we want 12 cups of water to actually answer our question. And so that's it. In this case, it does save us a bit of time to just multiply across because it gives us our direct answer. Sometimes you have to do a little bit of work. Sometimes it's not all that helpful. But, it's just a little trick that might come in handy. So keep that in mind if you don't feel like doing a lot of like messy algebra. So that's all that is. It's about setting these fractions, make sure that it's always the correct units and that it's consistent. So if you're going to do this whole question in terms of water to flour, you could just flip everything upside down, but just make sure it's consistent. And I would say also make sure that if you're doing like a word problem for this stuff, make sure that you actually define and you know what your x is. Like, what are you trying to solve? Because there are different applications for this kind of stuff. So sometimes you might be asked, especially in like chemistry and stuff, like you want to add a certain amount to something so that you keep a particular ratio. So that's a different thing, sort of. I mean, it depends on the question, but you might need to add the same amount to two different things, and so you might actually have like a plus x and a plus x on the bottom or something like that, but the concept is the same. You're still solving these kind of you're still kind of solving this proportion where you have a fraction or a ratio and you're setting it equal to something else. Or sometimes your x will be how much you want to multiply the entire thing. So in other words, how many servings of this dough am I going to get given So just make sure you define what your x is, right? Of course, adapt it to the question that we're working on. If you have any questions about this, definitely let me know. We can come back and work through specific practice problems. But I just want to get us into like this mindset. So last thing I want to mention is just briefly about rates and how this could tie into this kind of thing. Kind of related, you could kind of think about it this way, but let's say we're driving at 40 miles per hour. If you're a cool kid, maybe you're too good for the mile unit, so you can convert this into kilometers, but this you could think of in a way as a ratio if you wanted. In that you could relate, again, remember it's relating different values. So in this case I would basically be saying 40 miles to 1 hour, miles per hour. So in this case I'm relating the distance, the number of miles, to time 1 hour. And so this is assuming that we're traveling at a constant speed if we're driving at a constant speed of 40 miles per hour throughout. You could set a ratio here to say how many miles did I travel then in 2 hours if you were to drive at a constant speed, of course. But you could say how many miles did I travel and set that be x, and then do x over 3 and solve this. Of course, there are other formulas and other ways to think about this. Of course, just basic equation of distance is rate times time to look at this, but just, you know, conceptually and intuitively, you could also create this as a ratio, miles to time or distance to time. So don't know if that helps, but it was a requested topic, so I hope that this was nice and interesting. If you're asleep by now, I'm wishing you sweet, sweet mathy dreams. Otherwise, I will catch you for more math very, very, very soon. Thanks for hanging out with me. Much love. Bye.